Okay, can you see my screen, everyone?
Yes, sir.
Yes, sir.
My voice is clear?
Yes, sir.
Okay, fine. So let us start our class today. So basically, this is the second lecture of your this module. Then we will see what is about actually. We will a little bit about understand about the Unix process management. Okay. Now, the basically thing is that you have already learned about Unix in our in our operating system. So you have learned about operating system in your previous semester, right? So you have a little bit of idea that how does the operating system actually work. So among those operating systems, there are many kinds of operating systems are there, right? So there is what you can say, the Apple Macintosh computer system is there. Then you can say the what is the operating system. Then the Windows operating system is there. The Android operating system is there. So although Android is I think derived from although Android is derived from Unix. So and now in this class we will see about the Unix process management. How does things work in here? So basically, you already know that there are functions in two modes, right? There are two modes of operating system execution. One is the user mode and one is the kernel mode. User mode means where you are writing the code, you are sending function data to another function. The function is returning some information to you. That is the user mode. And then there is the kernel mode. Supposedly, you want to take certain input from the keyboard. So the part where the operating system calls a system call to read data from the device controller. One second. So the part where you have written a function in C. So the part where your code, so you have written the code, and the part where you are wanting to want an input from the keyboard, right? From a keyboard you want an input. So the part where the function calls the particular system call for reading the data from the that is memory the keyboard device controller, and it is sent to the memory. So the part of reading from the keyboard and sending it to the memory, that is done by the kernel mode. So for any process, there are two modes of execution. One is the user mode where you write the code. Another is the kernel mode where the operating system does the job for you that you cannot handle. Right. Now there are another again. So this you know already. So there are again two types of processes are available. What are the processes that are available? One second. The processes that are available are the system processes which execute the operating system code, and then there is the user processes which execute the user program code. One second. So basically, now let us understand that the processes, that is the operating system code, that is called the system processes, and then the user processes, like you're running the movie player, or you're running any simple C code, that can be called the user processes. So basically, the system call is used to transfer from user mode to system mode. So again, we are talking about modes in here. So basically, there is one single process. It might have two modes of execution, that is the user mode and the kernel mode. The system calls are used in here to transfer from the user mode to the system mode and vice versa. এখন পর্যন্ত বুঝতে পেরেছো কি সবকিছু বুঝতে পারলে?
Yes, sir.
Okay, fine. So what are the process states? So in operating system, you know there are certain process states were there. So what were the process states that were there? Initially, the process was in the then ready first in the memory, then running, then it might be waiting or there might be some interrupt might be there, and then after the execution, it was one for it is terminated. In Unix, we are using some more modes in there. So basically, the process states in here are basically, one second. The process modes are basically, one is the user running, right? That is executing in the user mode. Another process state is the kernel running, where it is executing in the kernel mode. Okay. Another one is ready to run in memory, ready to run as soon as the kernel schedules in, right? Or basically, if it is in memory, that is ready. Asleep in memory, it is unable to execute until an event occurs. So supposedly it is waiting for an event. The process is in the main memory or it is in a block state. That is what you can call as the asleep. Ready to run or swapped, the process is ready to run, but the swapper must swap the process into the main memory before the kernel can schedule the schedule the execution. Means the process is in the hard disk. So there are multiple, the process is broken into many parts that you have already learned in the previous operating system classes, and some part is in the hard disk, some part is in the memory. So the process is ready to run, but the swapper must swap the process from the main memory to the kernel. Okay, that is the basically swap. It is ready to run, but it is in some waiting. Not waiting, actually, it is ready to run or swap. Flipping or swap means the process is awaiting an event and has been swapped into the secondary storage. So the process is awaiting an event and has been swapped to the secondary. Means it is waiting, so it is not required to be in the memory, so it is swapped to the hard disk. Preempted means the process is returning from the kernel to the user node, but the kernel preempts it and does a process switch to schedule another process. Okay, so the process is returning from the kernel to the user mode. Right, it want to execute something in the memory, but the kernel what it does, it preempts, it takes the process away from the processor, and basically what it does is basically it schedules it another process to it. So basically, the process is in the processor, but it is transferred from the kernel to user mode. It is preempted. Another is the created. The process is newly created and not yet ready to run. So I have created a process, but I have not assigned memory to it. That means I have not put the process in the memory. And the last one is the process no longer exists, but it leaves a record for its process for its present process to correct. Zombie means in Unix the processes are not. They are basically becomes zombie. Zombie means they cannot run in the processor, but they exist. It is the duty of the parent process to collect the data from the zombie process and destroy it. Okay. So that is why we call process status for the Unix. Now let us see what happens in here. So initially, look at this part. So 1 second. So in here the process is created, right? So you see in here, whenever you are creating a fork command, so initially all the processes are in the, so initially when the Unix system starts running, there is a single process. When the system boot up takes place, that is called the process 0. After that, on one process starts running, that is called the process 1. So the process 1 is the parent of all other processes that are running in your Unix system. So another process that is created by you is actually not created by you. It is created by the Unix operating system for you using the fork system call. Right. Now the fork system calls, what it does, it creates the child process for your parent process. Okay. Now it creates, right? Now if the process has enough memory, it is put into the, so enough memory is present in the system, it is directly put into the ready queue of the memory. But if there is not enough memory for the process, some part of the process may be put in the memory, but some of the process is put into the, what you can call, in the hard disk or the secondary memory. From there, the swap in, swap out takes place. right? Now when it is in the memory, right, when it is in the memory, it is basically it can go to the kernel for running the schedule. It is basically called for the running in the kernel or in the what you can call in the processor. The kernel is running. Now it may return some data to the user process. So as a programmer, you might take some data from the kernel. Then again, you make a system call or make an interrupt to return to the kernel running. So the kernel is still running, So if it is still running in the processor, right, the processor is in the, it is still running, or in the kernel it is still running. So it might be preempted by another process. It might be preempted by another process. So if it is in the preempted mode, the process may return to the user, or it may return to the memory to again being scheduled. That may happen. Now, when the processor is running and it is waiting for an event to occur, it is waiting, so it can basically go into the sleep mode, or basically where it is taken out of the kernel and it is waiting for an event. So what it can do, so it can go to the basically secondary memory, swapped out. Again, it is basically waiting. So again, it can be if it is wake up. So if it wake up, it can go into the memory, or if there is not enough memory present, it can go into the secondary memory. So again, this whole thing runs till the process is completed. In this case, when the process is completed, it exists and it becomes a zombie state. বুঝতে পারলে? হ্যালো,
হ্যাঁ স্যার।
হ্যাঁ স্যার, স্যার এগুলো কি মেমোরি শিডিউলের মতো করে কাজ করে?
হ্যাঁ, একটু ধীরে ধীরে বলো।
হ্যালো,
হ্যাঁ, একটু ধীরে ধীরে বলো, একটু জোরে বলো।
স্যার বললাম এই যে এইগুলো মেমোরি শিডিউলিং এর মতো করে কাজ করছে?
হ্যাঁ, এটা ইউনিক্সের মেমোরি শিডিউলিংটা এইভাবে হয়।
স্যার প্রিএমপ্টেড স্টেটটা একটু বোঝাবেন।
প্রিএমপ্টেড স্টেট হচ্ছে প্রসেসরে রান করছে, প্রসেসরের ভিতরে মানে মেমোরিতে ঢুকে গেছে, ঠিক আছে, মেমোরি থেকে ঢুকে নিয়ে একটা প্রসেস একটা মানে এবার প্রসেসরে মেমোরি ইউজ করছে, মানে রেজিস্টার্ড মেমোরির মধ্যে কাজ চলছে, নিজের অ্যাডিশন, সাবট্রাকশন, ডিলিটেশন যা করছে, ঠিক আছে। হঠাৎ করে তুমি কি হলো, মানে এটা নিজের প্রসেসটা কাজ করে, তোমার সি প্রোগ্রাম হঠাৎ করে রান করছে, ঠিক আছে। হঠাৎ করে কি হলো, একটা মেল আসলো তোমার কাছে, ঠিক আছে, বা এটা হঠাৎ হতে পারে হঠাৎ করে একটা অন্য কোনো একটা জায়গা থেকে তুমি একটা ইভেন্ট করলে বা গেম খেলা স্টার্ট করলে, ঠিক আছে। এখন তোমাকে গেমটাও খেলতে হবে আর প্রোগ্রামটাও রান করাতে হবে। তখন কি হবে, গেমের যখন কার্নেলটাকে দরকার পড়বে বা প্রসেসরকে দরকার পড়বে, ও তখন প্রসেসরকে নিয়ে নেবে, বা নিয়ে নেওয়া মানে একটাই তো তোমার আগের সি প্রোগ্রামটা রান করছিল, তখন ও সি প্রোগ্রামের প্রসেস স্টেটটাকে সেভ করে ওটাকে পিএম করবে, মানে বাইরে করে দেবে, যেটাকে ও আবার মেমোরি ভেতরে রাখতে পারে বা ইউজার প্রোগ্রামিং এর রানিং এর ভেতরে রাখতে পারে, যেটা ইউজার মানে ইউজার হোয়াট ইউ ক্যান কল ইউজার মোডেও রাখতে পারে, ঠিক আছে। বাট ইট গোজ ইনটু দ্য প্রিএম্পটেড মোড, মানে ওটা চলে গেল, দ্য সি প্রোগ্রাম went out of the kernel or went out of the processor and your game is running in there. But after a while your game is finished, so the preempted process which can be in the user running or it can be in the memory, it comes back and to the kernel to complete its job. That is what we can call as the preemption. মানে সরিয়ে দিলে কিন্তু সে আসতে পারবে, ঠিক আছে। কিন্তু ম্যাক্সিমাম মানে ইউনিক্সে এটা হয় না, যখন কার্নেল মোডে চলে তখন প্রিএমশনটা অ্যালাউ করে না, সেই কারণে রিয়েল টাইম প্রসেসিংটা হয় না। এটা পুরনো ইউনিক্সে ছিল, এখন নতুন ইউনিক্সে হতে চেঞ্জ হয়েছে।
ওকে স্যার, মানে স্যার রেডি টু রান স্টেটে থাকবে তো?
না না, রেডি টু রান তো এটাতে আছে, মেমোরিতে আছে। যখন ও প্রসেসরে যখন রান করছে তখন ওটাকে কিন্তু কোনো একটা আলাদা কার্নেল অপারেশন কিন্তু ওটাকে প্রিএম্প্ট করতে পারে, মানে ওটাকে প্রসেসর থেকে সরিয়ে আবার মেমোরিতেও ঢুকাতে পারে বা ইউজার মোডেও নিয়ে চলে যেতে পারে, যেখানে তোমার কাছে কোনো ডেটা ফেটা যদি তুমি দাও থাকে।
ওকে স্যার, মানে যদি মেমোরিতে থাকে দেন রেডি টু রান।
হ্যাঁ, মেমোরিতে থাকলে তাহলে রেডি টু রান।
আচ্ছা,
okay, preemption can only occur when the process is about to move from the kernel to mode to the user mode. এটা একটা মানে for Unix system it is there, it occurs when the মানে kernel mode থেকে যখন user mode যেতে চায় তখন একটা preemption করা যেতে পারে, ঠিক আছে। কিন্তু যদি কার্নেলে চলছে it may not be printed। দেখো, এটা কিন্তু what we are studying is basically for Unix only. ঠিক আছে, আলাদা অন্য অপারেটিং সিস্টেমে দ্য থিং মে বি ডিফারেন্ট, বাট ফর ইউনিক্স সিস্টেম এখানে কি বলছে, preemption can only occur when the process is about to move from the kernel mode to the user mode. মানে যখন ইউজার মোডে আমি যেতে চাই তখন একটা প্রিএমশন হতে পারে। ঠিক আছে, মানে অন্য একটা প্রসেস এসে বলো তুই যা ইউজার কার্নেল থেকে ইউজারে চলে যা। ঠিক আছে, ওখানে তুমি কিছু ডেটা ফেটা ইনপুট করলে দিয়ে আবার ওটা তুমি মেমোরিতে পাঠিয়ে দিতে পারলে বা আবার কার্নেলে ওটা চলে যেতে পারে, যেখানে ইউজার মোড ইউজার ক্যালকুলেট করছে। While the process is running in the kernel mode, it may not be printed. In some cases of Unix, it may not be printed. ঠিক আছে, যদি কোনো সিস্টেম প্রসেস থাকে, যদি ওটা কাজ করতে থাকে, তাহলে it may not be printed. So এই কারণে Unix is not suitable for real time processing. Unix is not suitable for real time processing. মানে কার্নেলে যে প্রসেসটা আছে, যদি তোমার কোনো ভাইরাস বানিয়েছো, যদিও কার্নেল ফান্ডালে মানে একদম ইউনিক্সে যদিও মানে ভাইরাস প্রুফ বলা হয়, তবুও যদি কোনো প্রসেস যদি বানিয়ে থাকো যেটা শুধু কার্নেলে রান করতেই থাকবে, তখন কিন্তু অন্য কোনো প্রসেসকেও প্রিএম্প্ট করতে পারবে না। সেই কারণে ইউনিক্স ইজ নট সুটেবল ফর রিয়েল টাইম প্রসেস। তো আচ্ছা, এবার যখন ইউনিক্স আমরা বুট আপ করি তখন একটা প্রসেস জিরো ক্রিয়েট হয়। ঠিক আছে, তোমাদের ইউনিক্স তো সবাই ইনস্টল করে নিয়েছো তো সিস্টেমে?
হ্যাঁ স্যার।
আচ্ছা ঠিক আছে, তো যখন ইউনিক্স ইজ বুটেড আপ, সো প্রসেস জিরো ইজ ক্রিয়েটেড। তো হোয়াট ইজ প্রসেস জিরো? মানে এখানে কিন্তু হায়ারার্কিক্যালি প্রসেসগুলো তৈরি হয়। তুমি কিন্তু কোনো প্রসেস ক্রিয়েট করো, তুমি যদি একটা গেমও স্টার্ট করো, ইট ইজ ক্রিয়েটেড হায়ারার্কিক্যালি আন্ডার সাম প্রসেস, রাইট? ইট মাইট বি প্রসেস জিরো অর ইট মাইট বি প্রসেস ওয়ান, right? So process zero is a special process that is created when the system boots, right? Process zero is a special process that is created when the system boots. And process one, the init process, প্রথম যে প্রসেসটা যেটা ইউনিক্সে তৈরি হয় তাকে বলা হয় init process. Process one is the child of process zero. So process zero is booting process, process one is init process. So all other processes in Unix has process one as the ancestor. যা প্রসেস তৈরি হবে কিন্তু process one হচ্ছে গিয়ে তোমার root process, ওখান থেকে সব তৈরি হবে। Process one is the ancestor. All new processes are created under process one or the init process. So process description. So what are the elements of a process image, right? So it is divided into three parts. So one is the user level context, one is the register context, one is the system level context. এখন পর্যন্ত সবাই তোমরা বুঝতে পেরেছো তো?
হ্যাঁ স্যার।
ওকে ফাইন। আচ্ছা আমি 1 মিনিট একটু জল খেয়ে নিই, তারপর তো আসছি আমি।
আচ্ছা ঠিক আছে স্যার।
1 সেকেন্ড দেবো, 1 সেকেন্ড আসছি। Okay. So process description we are talking about, there are three parts. So one is the user level context, one is the register context, and one is the system level context. So in the user level context, what are the presents are there, what are the elements are there? That is the process text. মানে ইউজার লেভেলে তুমি যে কোডটা লিখেছো সেটা টেক্সট। প্রসেস ডেটা, যে গ্লোবাল ভ্যারিয়েবল গুলো ডিক্লেয়ার করেছিল সেটা। থার্ড হচ্ছে গিয়ে ইউজার স্ট্যাক, যেটা হচ্ছে গিয়ে তোমার টেম্পোরারি ভ্যারিয়েবল যেখানে স্টোর করবে বা ফাংশন অ্যাড্রেস স্টোর করবে সেটাকে বলা হয়। আর শেয়ার্ড মেমরি মানে হচ্ছে গিয়ে তোমার ডাইনামিক মেমরিটা, যেটাখানে তুমি লিংক লিস্ট বা যে কোনো কিছু তৈরি করবে সেটাকে বলা হয় ইউজার লেভেল কনটেক্সট। এটা তোমরা অলরেডি পড়েছো ইন দ্য ইউনিক্স ক্লাসেস। Then there is the register context. When the process is allocated to a kernel, or we can say allocated to the processor, then comes the case of the register context. One second. So in the register context, when the process is allocated, so every one of you are listening to me, right? Okay. So when the process is actually basically allowed to go to the register context, So it has some other elements are added to it. What is that? Is what? That is the what is the program counter means which instruction is it's running, process status register, which status it is in, stack pointer, ঠিক আছে কোথায় কোন পয়েন্টারে কোন ফাংশনে কি পয়েন্টারটা আছে, and other general purpose registers. Then there is the system level context. মানে operating system where does the process lie? It might be about the process table entry, which entry it is, what is the user area, what is the per process region table, what is the kernel stack. মানে all those clerical level data is stored in the system level context. So when a process is not running, the processor status information is stored in the register context area. ঠিক আছে? When a process is out of the, when the process is basically out of the means if it is preempted and if it is in the ready memory, so the information that is stored is about in the register context area. Okay, so now let us look into the what are the basically what you can say, what is the process context or what are the metadata information that are there within the process or about a process that is maintained in the whole operating system. একটা প্রসেস তুমি ক্রিয়েট করলে এটা একটা ক্রিয়েট হয়ে গেল, তুমি রান করে দিলে সেটা নয়। একটা প্রসেস যখন একটা মেমোরিতে রান একটা যখন প্রসেসরে রান করবে, so we have to store each and every metadata information about it. That is the information about the process. So what is its status? What is the process status? Pointers to the user area and the process memory area, that is text, data stack, all the pointers should be stored. Process size. So it enables OS to know how much space to allocate. So if your process is very big, like a very and if you are using a old age computer, desktop computer, then the operating system must know how much space to allocate to the process. Because if you are playing a game, it requires huge amount of memory. Now, what is the user identifier, right? So basically, as a user, you are creating a process. There can be multiple users in a process. So the real user, the ID of the user who is responsible for the process. Then there is the effective user ID, is used by the process to gain temporary privilege, ঠিক আছে, while the program is being executed as a part of the process. So temporary privilege can be anything, that is writing, reading, that is running execution rights, right? And process identifiers, that is the ID of the process. So event descriptor, valid when a process is in sleep state. When the event occurs, the process is transferred to a ready to run state. So basically, event is basically the process is in the sleep state and it is waiting for an event. So that event, what event it is waiting for, that event description has to be noted in the event descriptor. So when the event occurs, if the event after the event occurs, when the process is in sleep state, and it is waiting for the event to occur, and if the event occurs, the process is again transferred to the ready and or to the run state. Right. Now, priority, you already know priority scheduling. So what is the priority of the process? If it is a system level process, it has higher level priority, and if it's a user level process, it is a lower level priority. So all these priority information should be there. Signal, enumerate signals sent to process but not yet handled. So we are looking into the signals that are to be sent to the process, right? So it can be any information that we are trying to send to the signal. Okay, but the process has not yet handled those signals. So what is the timers? Process execution time. How much time does the process take? So these are all the basically what you can say the clerical level information that we are taking about the process. So process execution time means how much per time the process takes, how much the kernel resources utilized, how much the users and user set timer used to send alarm signal to process means when it will start, means when the process will complete its job. So these are the things. So you have seen that what happens that when you are transferring huge amount of your data from hard disk to the external hard disk or from your pen drive to the your secondary memory of the hard disk, then what happens? So you can get this information. So you have the processing, how much time it takes, you are notified about it, how much kernel resource it is taking. It might be it is taking so much resource that you are not able to do anything, that might happen. So how much user set time are you using, and you are signaling that how much the time is left. That is basically that signal that how much time is left, it can be given to the process. process image is in the main memory or swapped out. Okay, memory status means where in the memory does the process image lies, or it is either swapped out or not. Right? It is in the hard disk or not. Means there are certain valid, invalid bits are there. That means if it is in the memory, you can call it valid. If it's not in the memory, it is in the hard disk, we may call it invalid. So that's why the valid, invalid bit concept comes in. So again, the Unix user area means the process table pointer. So indicates entry corresponding to the user area. Okay, user identifiers. So real and effective user ID. If it's your process, you have some certain privileges, right? So record time. So timers are there to how much how much the process is executing in the user mode or in the kernel or mode. Signal handle area. For each type of signal defined in the system, indicate how the system will react to receive from that signal, right? So we have there are many kinds of signals are there that are defined in the system. So it might be some spike in basically CPU area, some spike in heat of the system. So these are various types of signals are there. So this can be used to indicate the process which will react to the receipt of that signal, right? Control terminal indicate login terminal. So sometimes you see that whenever the system is totally heated up, the system shuts down, right? So those signals also can be put in an array, and how the process will react to the receipt of that signal. So the process, if the signal can be also an error signal also. So if the process is what you can say, it is executing means it is trying to access the memory of other process. That time it might happen that an error signal is generated and the system might shut down. Right. There is the control terminal. So indicates login terminal for the process if it exists. Errors. Record errors encountered during the signal call. Good. So these are different information that are regarding there. So IO parameters are there. Basically, how much describes the amount of data transfer, the address of the source of the data array in the user space, file offset for IO. So all the IO these are there. So if a process is running in your processor, it might require input output memory, input output data from somewhere. Okay. So that thing is basically stored in the IO parameters. Then what are the file parameters of the user process? So the current directory the process is in, the current root. One second. The current directory and current root describe the file system environment of the process. So basically, what's directory, which current root, which file environment it is in. User file descriptor data. So record the file process as open, right? So which of the files are opened by the particular process? This has to be this information has to be stored. So limit fields. So limit fields, so there is a base and there is a limit. So if the process is working, so it has a base and it has a limit. What is the size of the process? Right. So restrict the size of the process and size of the file it can work. Permission mode field means mask mode settings on the files that process creates. So basically, whenever you are creating a file, so there are certain its permission changes, right? So if you are if you are opening a file in the write mode, so what happens? The file is not others to read them or write. So in that case, the settings of a particular field might change. Now, when you are talking about the system level context from the operating system point of view, there are two parts. One is the static, that is the process table entry. Means now when from the we are looking at the process from the operating system, right? So static means process table entry. What is the user area? What is the per process region table? It requires the total information that the process has. And the dynamic is the kernel stack. How much processor time it may change from different the kernel stack means that how much registers it is using or how much time it is using. Those are dynamic. So those keeps changing. So process table entry contains process control information that is accessible to the kernel or to the kernel all the time. So this is basically repeated statement. One second. Contains process confirmation that is accessible to the kernel all the time. Okay. So this information is accessible to the kernel all the time. So the VN systems or virtual machine systems or process tables are maintained in the main memory. So whatever data, what happens? So user area content. So every information about a process is stored by the operating system, and it is stored in basically in the table entries in the main memory. So user area contains additional process control information that is used by the kernel when it executes in the context of a process, right? So, and it is also used when the swapping process to and from the memory. So these informations are required by the system or the operating system for basically context switching and the swapping. So basically context switching means it is one process is preempted by another process, and the swapping basically where it stores the process states. And the swapping is that some part of the processes are in the hard disk and some some part of the process is in the memory. So in this case, the swapping means so it has to keep a track. The operating system has to keep a track what part of the process is in the main memory, what part of the process is in the hard disk. And so basically, it is helps in swapping the process from one part to the process frames from main memory to the what you can say from the main memory to the secondary memory. The process registers table is used by memory management scheme. Okay. Now then there is a kernel stack used when the process is executing in kernel mode and contain information that must be saved and restored as procedure calls and interrupts. Okay, so the process is executing in the kernel mode, and it also must have it's all the context information must be saved and restored whenever these procedure calls and interrupts might happen. Okay, এই এতটুকু বন্ধু বুঝতে পেরেছো? সিস্টেম লেভেল কনটেক্সট হলো, তারপর তোমার ইউনিক্স ইউজার এরিয়া কনটেক্সট হলো, ঠিক আছে, তারপর ইউনিক্স প্রসেস।
হ্যাঁ স্যার বুঝতে পেরেছি।
আচ্ছা, ইউনিক্স প্রসেস টেবিল মানে এতগুলো ইনফরমেশন আমার লাগে একটা প্রসেস তুমি যে ঢুকিয়ে দিলে মানে সিস্টেমে এন্ট্রি করে দিলে যে রান করার জন্য, তাই বলে হবে না কিন্তু ইউ হ্যাভ টু স্টোর ইচ এন্ড এভরি ডেটা অ্যাবাউট দ্য প্রসেস, দ্যাট ইজ হোয়াট ইজ ডিফাইন্ড ইন। এবার আমরা একটা সিস্টেম বানাই, ঠিক আছে, একটা হোয়াট ইউ ক্যান সে লেট আস মেক আস এ লেট। আচ্ছা, তোমাদের একজনের ইয়ে আছে, তোমার একটু মিউট করতে হবে। So in here we are creating a fork system. So just wait for 1 second. Just wait for 1 second. Come back to okay. So we are now want to create a child process. Can everyone hear me?
Yes, sir.
Yes, sir.
Oh, okay, fine. So now there is int main int argument character, ঠিক আছে, মানে এই main ফাংশনে কিছু argument character পাঠাতে হয়, ঠিক আছে। So it might be from the user level or it can be from the terminal process. So these are basically you get from the information that are received from the basically terminal. Int PID. So the process ID is created. So process ID is basically an integer field. So when you are creating, so what happens in this? So whenever you are trying to create another process, so we use the command fork. So PID fork returns what? Fork returns an integer which identifies a process within the system. Now, if it happens the process is not created, then we can say the fork failed, or the child process is not created. Or if so basically what you can say, if the process is basically equal to 0, PID is equal to 0, the child process is created, and it basically where it is created, so a slash bin ls, it is in the ls, okay. Or else if it is the parents, so parent will wait for the child to complete, right? It will wait and it will write when the child process completes its job, it waits for the child to complete and then it exits the command. So whenever you are writing a C program and you want to create a process, you have to use the fork command. পেরেছো এটা? This is a very simple code for implementing a child program. এটা বুঝতে পেরেছো নইলে আবার বোঝাতে হবে?
স্যার
আরেকবার।
স্যার এটা আরেকবার বলুন।
না, we want to create a child process, right? Now what is happening that in Unix you have to write a C program to create a child process from the parent process, right? Now what we do is basically from the terminal we try to create this child process. So everything we are, so think that the Unix doesn't have any basically GUI feature, মানে মাউস আমি ইউজ করতে পারি না। Okay, now what is happening now in this case that we want to create this child process, we have to create this one int PID. So int PID represents the basically the name or the number. So a process is identified by a particular number. So when I am writing int PID, so PID is an integer which represents the current child number. So now when I am writing the PID is equal to 4, মানে কি we are creating another child process from the parent process, right? So if PID is less than 0, we say that the error has occurred, right? And we write this fprintf, whatever the standard error function is, we can write this one, that is standard error that occurred and the child process is basically not created. But if the PID is equal to 0, right? If the PID is equal to 0, so in this case what we can call the current process image is replaced by the this one. We have to understand the child process actually replaces the current process image within the memory. Okay, so the one process memory is there and the child process which is created, it replaces the current current process image within the memory. And so /bin/ls, and ls might be the new command for it. Okay, and then what it returns is basically null, or else nothing is created. Basically, if it is PID is greater than equal to 0, then what is this? It is either a parent process or either it is the parent will wait for the child to complete. So in this case, the wait is becomes null, right? When the process the child has completed its jobs and it exits the job. বুঝতে পারলেন?
হ্যাঁ স্যার।
দেখে নাও আরেকবার।
হ্যাঁ স্যার দেখছি।
So the file is basically in here /bin/ls. You can write anything else. তোমরা এটা এক্সিকিউট করবে কি? তোমাদের কাছে সবার লিনাক্স আছে তো?
হ্যাঁ স্যার করব।
ওকে ফাইন। Okay. So what does the fork domain say? Allocates slot in the process table for the new process, assigns a unique process ID to the new process, make a copy of the process image of the parent with the exception of shared memory. ঠিক আছে? It increases counters for any files owned by the parent to reflect that an additional process now also owns these files. It assigns the child process to a ready to the run state. It returns the ID number of the child to the parent process and a 0 value to the child process. These all works are done by the kernel of the parent process. Okay. After completing these functions, OS will do the following operations as a part of the dispatcher routine. It will stay in the parent process. Control returns to the user mode and point to the fork pole of the parent. Transfer control to the child process. The child process begins executing at the same point the code to the as the parent, and namely at the return from the fork call. Transfer control to another process. Both child and parent are left in the ready to the run state. ঠিক আছে, এখানে কিন্তু কন্ট্রোল করছি আমি stay in the parent process যতক্ষণ ইয়েগুলো কমপ্লিট হচ্ছে so we are basically trying to what you can say is we stay in the parent process, we return to the user mode at point of the fork call of the parent. ঠিক আছে, now we are transferring control to the child process. The child process begins executing at the same point in the code as the parent, মানে ওখান থেকে যেখানে স্টার্ট হচ্ছে সেখানে এক্সিকিউট করা স্টার্ট করবে, ঠিক আছে, যেখানে রিটার্ন করবে, and we then transfer control to another process. Both child and parent are left in the ready to the run state. So exit status code কি আছে? Status code indicates termination status is closes all open. It does not destroy the process structure that is written till the parent of the PI destroys it. The termination process is dead, but it still exists. Hence, it is called a zombie process. The exit call also sends a signal to the parent of the PI, which may be ignored by the parent. আচ্ছা, আজ এই পর্যন্তই থাকলো।
ওকে স্যার,
ঠিক আছে, আর আমি নেক্সট ক্লাসটা নেব 11টা 10 থেকে। ঠিক আছে,
ওকে স্যার।
তোমাদের রোল নাম্বারটা দাও।